Today, we're going to solve the integral of sine x times cosine cubed x using the substitution method. Substitution is a powerful technique which can simplify integration by making a change of variables. Let's rewrite the integral for clarity. We have the integral of sine x times cosine cubed x. It's sometimes helpful to rewrite one of the trigonometric terms in terms of a power of another. In this case, cos cubed x can be split into cos squared x times cos x. Then we can observe that cosine squared x is equal to 1 minus sine squared x. And rearranging, we can write cosine squared x as 1 minus sine squared x times cosine x. This makes substitution easier. With all this considered, we will choose to let u equal cosine of x, since it appears more frequently, and the resultant expression only has one factor. Now, let's differentiate u with respect to x. Notice that the derivative of cosine gives us negative sine x. This should be our clue that the substitution is correct. Rearranging, the expression can be rewritten to solve for our differential x term by writing dx in terms of du. Now we can substitute into our integral. Remember to replace dx with dx equal to negative du over sine x, and write sine x cos squared x cosine x all in terms of our substitution, u. Now notice that the sine terms cancel out. So we integrate the integral of u cubed times negative du, and resolve with our final expression. As we know, the power rule of integrals gives us u raised to the next higher power n plus 1 divided by n plus 1, so this becomes negative u to the fourth power divided by 4, plus a constant of integration. Now, we can substitute back in terms of x rather than u, since u was chosen to equal cosine of x. So our final integral solution is negative cosine raised to the fourth power divided by 4, plus a constant. Let's reflect on how substitution helped us solve this. This integration showed us how deciding on a good substitution can allow us to rewrite parts of the integral to a friendlier form after differentiating the substitution. It's inserted into the integral by rewriting the original dx equals du coefficient. This substitution method allowed us to simplify to a straightforward polynomial, making integrating easier. Thank you for learning with us.